Hello everyone and welcome to my mathematics class today. My name remains Mr. Dickson. Let me seize this opportunity and thank all of you who have been viewing my videos, subscribing and sharing. Please continue. God bless all of you. In today's class, we will look at special triangles. Why do we need to look at special triangles? We want to look at different other forms of obtaining the ratios of angle 45, 30, and 60 degrees. You know, most time you will see question, they don't want you to use four-figure table, they want you to use short form to solve. In order to use short form to solve, you must understand how to obtain the short form of 45 degrees, 30, and 60 degrees. Okay, we will make use of a right angled isosceles triangle as usual. Look at the picture of a isosceles triangle. Okay, let me close it a little bit so that it will not be as equilateral. Isosceles triangle is that triangle that has the both sides here equal. That means side AB and side AC are equal. So we're going to bisect perpendicularly, and now let me call this point P. Let me also bring out the right angle part of it. Let me bring out the right angle part of it. Okay. Alright, this is 90 degrees. And now I want to make use of the side 1 unit. Side 1 unit. That means this is 1, this is 1. Meaning that this place at this point is 45 degrees. Here is also 45 degrees. This is 90. We add this to this, we're going to have 90. So with this now, I pick my A, I pick my C, and now this point now, I put P. Now, before we can obtain the ratio of 45 degrees, we need the hypotenuse side. Take note, now I am considering 45 degrees. Meaning that this side now is corresponding to this angle. This is the opposite, this is the adjacent, and of course the side corresponding to angle 90, that is the AC, remains the hypotenuse. Okay, now I must obtain side AC. How do I do that? That is when I need to apply Pythagoras theorem. So now side AC, I can have that AC squared is equal to AP squared, then plus CP squared. What is AP squared? That is 1 squared plus 1 squared. Yeah. Now this is equal to 1 plus 1, and that is equal to 2. Okay, at this point, that means AC squared is equal to 2. What is AC? AC automatically becomes the square root of 2. Obtaining the square root of 2 simply means we have been able to obtain the side AC. We have square root of 2. Okay, now permit me to remove this angle so that we can view our stuff well. Okay, now let us now obtain the ratio of angle 45 degrees. I start with the sine 45 degrees. What is sine? Sine is opposite all over hypotenuse. We are considering angle at this base, which is corresponding to this side that is opposite. So opposite is 1, hypotenuse is root 2. That means that will be 1 all over root 2. Some literature will put it as, mathematical literature will put it as root 2 all over 2. Okay, now what is cos 45 degrees? Cos 45, cos is adjacent all over hypotenuse. That means 1 all over root 2. It's the same thing as sine of 45 degrees, which is the same thing also as root 2 all over 2. I hope you remember how we obtain this. Quickly, if you have 1 all over root 2, since root 2 cannot be left as the denominator, so that means you must multiply both the numerator and the denominator by root 2. If you do that, 1 times root 2, that will give you root 2 give you root 2, then root 2 times root 2, which is 2. So that is how we obtain this. Okay, let's go back. So we now want to obtain tan 45 degrees. Tan is always opposite all over adjacent. That means 1 over 1 will be the same thing as 1. So we have been able to obtain the ratios of angle 45 degree. So we're going to do the same thing to angle 30 and angle 60 degree. Okay, at this point, I want us to go on a short break. As we return, we will prove both 30 degrees and 60 degrees. Don't go away and stay tuned.